use and/or view at your own risk. In this video, we're going to take a look at the TCP IP Netstat command. This video is more for someone who has never used the Netstat command, so if you were just trying to remember some switches or how to look up an address or something like that, that'll be at the very end of this video, and I will separate it out into a much smaller video for those of you who are used to using or have used the Netstat command before. Netstat is short for Network Statistics and is a command line utility, or more precisely a console application. As its name suggests, it displays protocol and network statistics for all network interfaces attached to the computer. A network interface, more commonly referred to as a network interface card, is really any piece of hardware that allows the computer to connect to a network. The two most common types are a USB wireless adapter and a PCI Network Card, or a NIC. Netstat's main scopes are TCP, which stands for Transmission Control Protocol, UDP, User Datagram Protocol, IP, Internet Protocol, and ICMP, Internet Control Message Protocol, for both IPv4 and IPv6. To use it, open the command prompt, which is normally found under the Accessories folder in the Start menu. So we'll need to go to the Start menu button, click it, then All Programs, click it, or just wait for it to open up by itself depending on how your computer's set. Then the Accessories folder, click it, then we'll need to hover our mouse cursor over the command prompt shortcut, right click it, and then select or click Run as Administrator. Now we are presented with a user account control warning. We'll select Yes to it, and then the command prompt window will open up. Now, in order to run a couple of switches, namely the B switch of the Netstat utility, we'll need to have elevated privileges, or we'll need to be running as an administrator. And to make sure that you are doing that, you can always look at the command prompt window title, and it'll be prefixed with the word administrator. Now that the command prompt window is open, the first thing that we'll want to do is type in netstat, N-E-T-S-T-A-T, a space, /, then a question mark, and press the Enter key. This will bring up the Help menu for the Netstat utility and display all of its switches and a brief description for each. Switches are additional commands that display specific information the Netstat utility is able to retrieve. The available command line switches are as follows, and as also is shown on the screen: Netstat-A, Netstat, excuse me, Netstat-B, Netstat-E, Netstat-F, Netstat-N, Netstat-O, Netstat-P plus a designated protocol, Netstat-R, Netstat-S, Netstat-T, and Netstat with a time interval. The switches are able to be used in conjunction with each other. The spaces between them are required, and the case is ignored. So let's go ahead and scroll up. Now the first thing that we're going to do is just type in the netstat command with no switches. So we'll type in N-E-T-S-T-A-T and press the Enter key. Now you'll see that we get a main heading of active connection, a subheadings of proto, which stands for protocol, local address, foreign address, and state. And right now on this particular computer, we're not showing any statistics. When you run the netstat command for the first time, you may actually receive some statistics for the if you have an active connection going. We don't have any statistics because we don't have an active connection. So in order to rectify that, what we're going to do is just open up the Google Chrome web browser. That will make an active outgoing connection to its set home page, which happens to be my website. And now the computer has an active outgoing connection. So we'll rerun Netstat. We'll change our focus back to the command prompt window. Rerun Netstat. Press the enter key. And now you can see that we are actually getting some statistics for the Netstat utility. By default, the TCP protocol, then the local address, then the foreign address, and then lastly the state will be shown. Now the local address is the address of our network interface card and is usually supplied by our gateway by the use of a dynamic host control protocol or a DHCP server. The foreign address is the address the local address has called out to, and then the state is the state of the current connection, and in this case it's established. Right, just to give you a little bit of an idea what this stuff means. Now the connection status or state can have several values, as you see here, and the most common are listed in the description below and are loosely defined. And there's also a link in the description to give you a more in-depth look at the possible states that your connection can be in. Now we're going to go ahead and scroll up. Now as far as navigating under the command prompt, you can use the up or down arrow keys on the keyboard to re-enter any previously entered commands in their entirety so that you don't have to retype them, or the right arrow key to enter the last command shown or entered one character at a time. So I'll go ahead and show you that. So just press the up arrow key one time and you'll see that the last command, which was just the Netstat command without any switches, was automatically re-entered for me or auto-completed for me. I'll press it again. It goes back to the very first one that we put in, which is the Netstat command with the help menu switch. We can also back up, get rid of all of that, and then use the right arrow key in case you made a typographical error or something like that, and enter the last displayed command one character at a time. We can also use the clear screen command, which is CLS, which stands for clear screen, and press the enter key, and what that'll do is clear the entire screen when it becomes too cluttered to be able to read comfortably. The first switch listed was Netstat-A, the Netstat command with the A switch. So let's go ahead and use our little shortcut. Add Netstat, a space, the minus sign, and then the A. The minus sign and the forward slash both infer that a switch is to be used. Some switches do not require either, such as the time interval switch, which we'll look at the very end. So we'll go ahead and press the enter key. Netstat-A or Netstat with the A switch will display all active connections no matter the protocol and any ports that are currently listening. So the default protocol is TCP, but since we use the A switch, which is commonly referred to as the all switch, it's going to display all active connections and listening ports. So we have the IPv4 listening ports, the IPv6 listening ports, and then all active connections in between them. And the reason that we aren't showing any IPv6 IP addresses is because IPv6 is disabled on this computer. It just keeps things a little bit simpler for those that aren't used to dealing with this kind of stuff. So we'll come back and we'll use our little CLS shortcut or command, press the enter key, that'll clear the screen, and we'll move on to the next switch. We use our autocomplete. Boom, boom, boom. Backspace, add the B, press the enter key. The Netstat-B switch will display the executables and or programs that are responsible for creating the connections and the specific ports used. This will display the TCP protocol by default, then the local address, then the foreign address, then the state, and then underneath that in brackets it'll show us the executable or program that is responsible for creating the connections. Okay. So we'll clear our screen. And we'll move on to the next switch, which is the E switch. Backspace, add the E, press the enter key. This switch will display the Ethernet adapter or adapter statistics. This switch will also include wireless adapters, contrary to what its description may seem to imply. The information displayed will be the statistics received and sent for bytes, unicast packets, non-unicast packets, discards, errors, and unknown protocols. Clear our screen again. Move on to the F switch. And F, press the enter key. Netstat with the F switch will display the fully qualified names for the foreign address only, also known as the FQDNs. This will include the host name, which is before the first period here, that's our host name, as well as the domain name, which is after the first period. Now all other stats displayed are as the default, the TCP, local address, and state. And you may notice that the HTTP and HTTPS ports are displayed in non-numerical format. So you can see that the HTTPS, I don't really see an HTTP port is displayed in non-numerical format. Normally that port is really port 443. And the reason that it's being displayed here in non-numerical format is just simply for clarity. So we'll go ahead and clear this out. Move on to our next switch, which is the N switch, I believe. Press the enter key. Now the N switch will display all addresses in numerical format. So the aforementioned colon HTTP and colon HTTPS ports will also be displayed in their numerical forms instead of the non-numerical forms. So it'll be HTTP will be displayed as port 80, and HTTPS will be displayed as port 443, as you can see here. But all addresses when you use the N switch will be displayed in numerical format. Okay, we'll go ahead and click. Move on to the next switch, which I believe is the O switch. Press the enter key. Now Netstat with the -O switch will display all process identifiers associated with each connection. The process identifier is a unique number assigned to an active process by the system kernel. The process ID can be discovered through the task manager. So what we'll want to do is we'll want to come down here and right click the taskbar, then select Start Task Manager, and you can see here that just happened to land on the Process tab. But if it didn't, go ahead and click the Process tab, and you can see here there's a column that displays the PID or the PIDs for each process. If this column doesn't appear on your computer, that's totally normal. Just go to the View menu item, then down to Select Columns, click it, and then what this allows you to do is set the columns that's going to be shown under this tab, and just make sure that a check mark is placed by PID or process identifier. So I'll just show you, right click, I'll uncheck it. You'll see that it disappears. Come back, set columns, recheck it, and you'll see that it reappears. Okay. Now we can just take a look at the PID under our command prompt window and see that it's telling us that the process ID that created this connection is numbered 3948. So we can just come down here and look, and we can see that Chrome.exe is numbered 3948, which we already knew that. If for some reason you see a PID listed here that's not listed in the task manager, just go down and click the Show Processes from All Users, and that should show you all the processes. And if for some reason you saw a PID listed in the command prompt that was not listed in the task manager, even after you click show processes from all users, that's a very good indication that you've got some malware on your system. So, because what it'll try to do is it'll try to hide its PID. So we'll go ahead and close that. Refocus on our command prompt window. Clear the screen. And we'll move on to the P switch. So, add the P. Now this switch actually requires a protocol to be defined, and the syntax is as follows, and I'll show you right here. So it'll be netstat space -P space then a protocol. Now I'm going to just type in the default protocol, because honestly the only outgoing connection that we have going on is the Google Chrome web browser, and it's not going to show any UDP statistics or ICMP statistics or anything like that. The only statistics it's going to have is for TCP. So then I'll go ahead and hit the enter key, and you can see now we have some statistics. And this is per protocol. Like I said, I'll show you that the web browser isn't going to have any kind of, or normally isn't going to have any other protocol statistics. So user datagram protocol, press the enter key, and you can see that we don't have any statistics. Let's go ahead and clear that. The next switch is the R switch. So we'll use our autocomplete, back it up, add the R switch, press the enter key. This switch will display a list of network interfaces, which you can see here. The IPv4 and IPv6 routing tables, also known as RIBs, and any persistent routes associated with each. The routing table is used to determine the interface to be used and the forwarding IP address, the next destination IP, of a packet of information being sent over the connection. Think of it as a map for the travel of information. The active route information displayed is as follows: the network destination, then the net mask, also known as a subnet mask, then the gateway, then the interface, then the metric. The metric usually indicates the number of hops. The route with the least or the lowest metric value is normally automatically chosen. And you can also see up here in our interface list that it gives us our MAC address. MAC stands for Media Access Control Address. It's also called the physical address of our network interface, and it is usually unique to each network interface, although there are some programs that can be used to actually change your MAC address, but that's a whole nother thing. So we'll go ahead and clear the screen again and move on to our next switch. The next switch is the S switch. So we'll add that, press the enter key, and you can see that it shot an extreme amount of information at us there. So the S switch will display statistics by protocol, and the protocols that will be displayed are as follows: IPv4, IPv6, ICMPv4, ICMPv6, TCP for IPv4, TCP for IPv6, UDP for IPv4, and UDP for IPv6. The stats for each protocol are too numerous to list in the description below, but you can see them here. It gives you, like I said, a lot of information. So we've got packets received, received header errors, received address errors, so on and so forth. And what you can do is just research all of this information and get a better understanding of what all this means. We'll go on down, clear our screen, and we'll move on to the T switch and press the enter key. Netstat with the T switch will display the current connection or connections offload state, or the TOE. The TCP/IP offload engine is usually associated with high-speed data transmission, although its origins stem from the old modem days. Now it's used because high-speed data transmission could overwhelm the CPU, leaving little processing power to perform other functions. This command will display the active connection or connections, its protocol, its local address, its foreign address, the state, and the offload state. Now the TCP chimney offload can be disabled or enabled, and a returned value of in-host, which is what we have here, means that offloading is not occurring. Accordingly, a returned value of offloading means that offloading is occurring, and a transfer of the workload has been moved from the CPU to the network card, or the NIC. The network interface card must support TCP offloading, and it must be enabled in both the advanced properties of the interface and the operating system. And you can enable it under Windows 7 using the netsh command. Go ahead and clear the screen again, and now we'll go to our last switch, and we'll just use the B switch. The last switch is actually the time interval switch. So it's a little different. It doesn't require a minus sign. It doesn't require a forward slash. And all that this switch does is allow us to rerun any particular command with or without switches at with a designated time or under a designated time. So if I want to run netstat-b every 7 seconds, this is the syntax. I type in netstat space -b, then another space, and then a 7, and then S for seconds, and press the enter key. And now you can see that netstat-b ran. It'll wait 7 seconds, rerun, wait 7 seconds, rerun again. Okay, and so what this switch can do is allow you to look for any changes that may occur, over a specific period of time. And in order to stop it from rerunning, what we'll need to do is press and hold the control key and then press the C key, and that'll escape us out of it. So we'll bring it back up, clear the screen. Now we're finally going to get to some practical uses of the netstat command. But it's important to understand what you're doing so that you can know what you can do. But mostly the netstat command is used to do one of two things. Either troubleshoot your network because you can't reach a network attached storage machine and you don't know what's going on, you don't know why, what's stopping it, or to see where your computer is actually calling out to. Now, calling out to a website, as we've done, is not that big a deal. But if you had a piece of malware or something like that on your system and it was calling out by itself, and there wasn't a web browser open or anything like that, this is a way to discover that and to discover where it's actually calling out to. So what we'll do is we will put in the netstat command with the A switch, space, then we'll add the O switch, another space, then we'll add the N switch. Now, we know that the A switch means all, which will show us all connections and listening ports. The O switch will display the PIDs, or the process identifiers, for the files or executables that are responsible for creating the connection. And the N switch will display all information in its numerical format so that we can track down the IPs. And so we'll go ahead and run that. And you'll see, of course, we have all connections established and the ports listening. We have the PIDs for all the connections. And we are showing the foreign addresses and everything else too in numerical form. So say I'm wondering, I know that my local address is my computer, and I can see here that my local address is 192.168.1.130, colon, then the port that is calling it, this particular connection is calling out on is 49,884 or 49,884, and it's calling to a foreign address of 74.125.196.188, and that foreign address is using the port 55228. But I don't know who this 74.125 guy is, and I want to find out. Okay, and we've already seen how to see what the executable is, or the file is, that's creating this connection is. We'll go down to our task manager, start it. We're on the process ID tab. It's what, 3948. We go down and we see that 3948 is Chrome. Like I said, we already knew that. So what you'll need to do is you'll need to go to a website that's capable of doing what's known as an IP address lookup. And not only can you find out who that IP address belongs to, but with certain websites they actually allow you to do an IP address location too. So it'll show you what organization or who that IP address belongs to and where it's located physically, if it's able to pick up that information. Sometimes it's not, and it'll default off to a generic location, so you kind of have to be a little careful about that, which I've learned recently. So I happen to have a shortcut to a website that will do this, and we'll just go to dnsstuff.com, and I'll go ahead and close this keyboard out. We don't need it anymore. And you can see here that this website allows us to do a IP whois lookup. So we want to know who this 74.125 guy is. So we'll come up to the window menu, click it, then come down to edit and select mark, and this will allow us to highlight or copy information in a command prompt window. And we'll hold our cursor down, or mouse cursor down, and then select the IP address. You don't need the port. Then you'll come back up here and we'll go back to edit and select copy, or you can simply just hit the enter key and it'll copy it to the clipboard. We'll go ahead and do that. Now we'll come back to our website, enter it into the IP whois lookup box, right click it, select paste, go ahead and get rid of a few trailing characters or prefixing characters there, and then press the button beside it or hit the enter key. This will go out and do a lookup. Now you can see the results for target 74.125.196.188, and we can come down here and look and see that it's Google. Okay, so there's nothing to worry about there. So this is how you can find out where your computer is calling out to, or if you were to hit some kind of bottleneck and say your router wasn't allowing it past the router. There could be several reasons for that. You may have Google blocked, or you can use the Netstat command to find out not only where your computer is calling out to, but it will also give you an idea of what the trouble may be if you can't make a connection. So I hope this video wasn't too confusing, and we'll see you in the next one. And thank you for watching.